Welcome to the Explainer, everyone. Today, we're kind of flipping the script on how we look at science. We often get totally boxed in by this textbook-heavy view of the world, just memorizing facts and keeping subjects in their own little lanes. But today, we're tearing those walls down. We're going to explore how science actually operates out in the real world, literally without boundaries. And to kick things off, I want to jump straight into this completely mind-boggling estimation that, well, you are actively participating in right this very second.
10,000. That is the staggering number of liters of air you breathe in a single day. 10,000 liters. It sounds huge, right? Like almost impossible to know for sure unless we, hook you up to some fancy medical machine, but not exactly. Okay, let's dive into this, because how we actually arrive at this number reveals something super cool about how scientific thinking works in practice. We don't always need absolute perfect measurements to find the truth or wrap our heads around reality.
Let's just walk through the logical steps of this estimation together. So, step 1. When you're just sitting there at rest, you take about 12 to 15 breaths a minute. Over a whole day, which is 1,440 minutes, that multiplies out to roughly 20,000 breaths a day. Okay, step 2. How much volume is actually in one of those breaths? Well, think about blowing up a standard 2-liter party balloon. It takes what, maybe 4 or 5 normal breaths to fill it up? That means one single breath is right around half a liter. So step 3 brings the whole shebang together. 20,000 breaths times 0.5 liters, bam, there's our 10,000 liters. What this shows us is that science doesn't always need exactness right out of the gate. Actually, scratch that. It's more like sometimes a logical approximation is a brilliant tool to grasp the immense scale of the world around us.
But hey, we are critical thinkers here, right? So let's verify our math using the source text. We can do a quick check, the 3-balloon-per-minute test. If you could blow up one 2-liter balloon in about 20 seconds, you'd fill 3 balloons a minute. Multiply 3 balloons by 2 liters by the 1,440 minutes in a day, and you get 8,640 liters. This practically proves our 10,000-liter estimate is perfectly reasonable. Now sure, blowing up balloons non-stop for 24 hours would make us ridiculously tired compared to just normal, restful breathing, but it absolutely proves our initial logical framework is rock solid.
And this brings up a fantastic point. I want you to just pause and ponder this for a second. Think about your own everyday life and contrast a couple situations in your mind. Can you describe one scenario where an approximate answer, like our 10,000 liters of air, is totally 100% good enough? Now contrast that with a scenario where an exact value is absolutely vital. Like you certainly wouldn't want an approximation for a dosage of a critical medicine, right? No way. But it's completely fine if you're just estimating how much paint you need to buy for your living room wall. Figuring out when to use which, that is a core scientific skill.
Now, shifting gears just a bit, let's look at how we're traditionally taught to view the scientific world. You've got physics, chemistry, biology, earth science. If you think back to your school days, especially around, say, grades 9 and 10, science is chopped up into these neat little branches. It divides the subject up just to organize knowledge for tests and textbooks. But it kind of creates a myth. It makes us subconsciously think that biology happens in one room and physics happens in another, completely walled off from each other.
But here is a massive paradigm shift, and I absolutely love explaining this. The natural world has no boundaries. I really want to let that sink in for a moment. The natural world has no boundaries. Those academic divisions between chemistry, physics, and biology, they are entirely human-made. The universe honestly doesn't care about the label on a textbook. The reality we live in operates as one seamless, wonderfully interconnected system, completely independent of how we've decided to categorize it in a classroom.
And this brilliantly illustrates why recognizing this matters so much. When we step outside that classroom and look at modern, massive challenges, they absolutely require ideas from multiple disciplines at the exact same time. Think about it. Understanding climate change isn't just earth science. It involves the chemistry of the atmosphere, the biology of ecosystems, and the physics of heat transfer. Developing new medicines? That's chemistry and biology working hand in hand. Designing sustainable technologies demands engineering, physics, and ecology all at once. Science naturally connects with math, tech, the arts, and social sciences to actually solve real-world problems.
Let's ground this high-level concept in an everyday reality we are all incredibly familiar with now, the surgical mask. During the COVID-19 pandemic, these became, well, a daily necessity for our safety. But I gotta ask you, how does a simple surgical mask actually work to keep us safe? If you think it's just a tiny physical net catching big particles, you're missing the true interconnected genius hiding literally right in front of your face. Now, what's really interesting about this is exactly how we can deconstruct that mask to see all the sciences collaborating at once. First, biology tells us about the microscopic size and the behavior of the viruses we're trying to block. Then, physics comes in, because it's not just a physical barrier. Masks actually use particle motion and electrostatic attraction to magnetically grab onto those tiny viral particles. Chemistry is absolutely crucial for engineering the specific properties of the polymer fibers making up the mask's layers. And mathematics is used to model the airflow and calculate the actual filtration efficiency. That's 4 distinct branches of science, working together in a millimeter-thick piece of fabric to solve a single real-world problem. Isn't that wild?
So now it's your turn. What sciences are hidden in a pressure cooker in your kitchen, a traffic jam near your house, or even the mobile phone in your pocket right now? I'm challenging you to be an active participant here. Do a quick mental sketch. What ideas from physics, chemistry, biology, earth science, or math are involved in those everyday things? Try to show how at least 2 branches connect in your example. I promise you, once you start looking for these connections, you are going to see them absolutely everywhere.
This incredible interconnectedness leads us right to the philosophical core of what science truly is. Science is fundamentally a human activity. It's not just a cold collection of facts or equations or some isolated lab experiment. It is a dynamic, cultural, and generational pursuit. It's deeply shaped by human curiosity and creativity. It's driven by collaboration between people all across the globe. It is built on careful questioning. And most importantly, it grows by testing ideas, sharing results, and yes, learning from our mistakes.
So the crucial point is this. Even if you don't plan to study science past grade 10 or, ever work in a laboratory, scientific thinking is incredibly important in whatever you do. It empowers you. It helps you critically evaluate the absolute flood of information you see every single day online. It helps you understand the complex technology that surrounds you, and it fundamentally helps you make sense of the world you live in. You do not have to be a professional scientist to be a scientific thinker.
I want to leave you with this beautiful, really powerful metaphor from our source material today. As you navigate your life, I invite you to embark on your own journey of discovery, looking carefully through the magnifying glass of evidence and guided by the compass of curiosity. Never stop questioning the boundless world around you. After all, if a simple face mask holds the secrets of physics, chemistry, biology, and math, what hidden sciences will you uncover in your own home today? Thank you so much for joining me on this explainer, and hey, happy exploring!